All right. Hello, everyone. My name is Ilya Grigorik. I'm a developer advocate for the Make the Web Fast team at Google. And I also spend a lot of my time with Google Chrome, or I should say I almost live in Google Chrome. I develop, I debug in Google Chrome. I do many different things in Chrome. So this session is about some of the tips and tricks that I personally find very useful. And I know this is the end of the day. In fact, I can't believe they have a session at 6 p.m. because I know that by this point, I'm usually, like, my brain is fried after a full day. So my plan here today is to just completely overwhelm you with a collection of tips that will hopefully, you'll find something useful. So broadly speaking, there's two parts. And the slides are actually online. I really encourage you guys to either follow along as I'm doing it here, or more likely maybe try it at home, because it's one thing to just watch somebody use some of these tools and another to actually play with it, especially play with it on your app. So two parts. First part is going to be more about the actual DevTools, like what are the kinds of things that DevTools provides today that will allow you to optimize your app, find problems, performance problems, and the rest. And then the second part is probably my favorite part, which is how can we extend DevTools? Because there's a lot of different ways, very powerful ways that we can do that and leverage that. So without further ado, let's get right into it. And let's start with the basics, right? We all know DevTools. We live in the console. We of course know the elements. So the simplest thing that we can do is, of course, just right-click on any element and inspect an element. Nothing new, but maybe one thing that you didn't know is, let me actually make this a little bit smaller so we can see the list. We can actually drag, or we can select any element and drag it up and change its position. Okay, so not too exciting, but that's pretty basic. Now, I tend to work on a lot of apps that are JavaScript driven, which means that there you click on a button, something changes in the DOM, and sometimes I'm just trying to figure out like what function is calling what, who's making this. Who's doing the work. So one cool thing that you can do is you can right-click on the element. You can say, hey, I want you to put a debug point on a subtree modification, a node removal, or just if something changes with respect to this element, which is really cool. So let me set a breakpoint for node removal. So if anything triggers a node removal, we should jump into the debugger. And then, of course, I have a convenient delete me button here. If I click on this, look at that. We pause in the debugger. And if I scroll over here, you can see the actual code that's invoking this function. So I can, of course, play resume or hit resume, and everything continues. So just a very handy feature if you are debugging your apps. Of course, another nice thing is if we go back to here, if we bring up the console, any element that you have selected, $0 will give you access to that. So you can just click on any element in the DOM and you have immediate access to it. So you can query it, you can interrogate it, look at its properties and all the rest. So nifty features if you didn't know about them. Now, before we get too far into this stuff, I want to emphasize one thing, which is if you haven't already, really go and look in the settings of your DevTools. We keep adding new stuff in there. In fact, you should, if you are developing in Chrome, you should install Chrome Canary and then go into settings and just play around and actually check back every couple of weeks, because we add new stuff, we disable some stuff that doesn't work. So some of my personal favorites, I do a lot of performance related work, which is to say, how can I improve the page loading time of this application? Disable cache, incredibly useful. So what this does is when you have developer tools open and you reload the page, we bypass the cache for you. So of course you can do that yourself by doing like a shift reload, but half the time you forget, like, oh, I forgot to do that, and then some of the assets come from the cache and you're not getting the complete picture. So disable cache only works when you have developers tools open. So don't worry about keeping that enabled all the time. That's just a handy thing. Show paint rectangles. This is an amazing feature, and we're going to look at it in a few slides in detail. Console, so log XML HTTP requests. If you are developing a very Ajax-heavy app, now this is a very interesting feature in the sense that for every request that the browser makes, it'll actually log the object into the console. So then you can open up in console and look at all of its properties, etc. Your mileage will vary with the kind of usability of this thing. You can, of course, also look in the network panel, but oftentimes you find yourself kind of sitting in the JavaScript console, interacting with your app. That's a very quick and nice way to get at it. And then the last one that I'll mention, this is kind of a personal pet peeve. I do a lot of my CSS markup in in hex, right? I specify the colors in hex, and then I go into DevTools, and it completely reformats it in like HSL or whatever the other format is. And that always annoyed me until I discovered that I could actually just flip the default and go back. And there are good reasons why you would actually want to have one of those. For example, in HSL, when you have a color in your CSS toolbar, you can click on that, and it will give you a nice color picker where you can just like change the hue or change the opacity or something else, which is really nice. So just a couple of quick tips. Network timeline is where I spend probably the majority of my time. And there's a lot of stuff to be said about the network timeline. I know that after a while, after staring at, there's actually so much data packed into here. So I want to unpack some of it, because after you stare at it for a while, you start to miss things. So for example, and I will submit to you that maybe this is not the most intuitive UI, but stay with me. We have requests here, right? So we have these objects which are being used to render the page. Now, we have actually two values here. We have size and content. So if you look at this, right, we fetch the page, which is 10 kilobytes in size, but the content is 41 kilobytes. What does that mean? Well, it means that we got 10 kilobytes on the wire, but those 10 kilobytes expanded to 40 kilobytes. What does that tell you? It tells you that we're using compression, right? So just very quickly, you can scan through a lot of these resources and figure out, am I applying compression on these resources? So you can flag assets that are not being, for example, gzipped. Similarly, we have the time and latency column. So what do these numbers mean? So for example, this request right here, we have time 1,000 milliseconds, which is 1 second, and then the latency is 339. What this tells us is the duration of the request was 1 second. That is the total time for us to connect, submit the request, or maybe even connect the TCP socket, and then fetch the body, and then we can parse it. Whereas latency is the time to first byte, which is to say there are many different ways that the server could respond. They could respond almost immediately and then kind of very slowly stream the data back to you, or it could batch up all the data and just kind of shove it in one packet later. So this allows you to figure out, how's my server behaving? Maybe my request is getting queued in a long queue, and that's why you would have long latency. And then the last one I'll show you, here I have an actual page, is you can actually, so you can look, of course, at these numbers here, right, and kind of figure out like which of the requests are getting queued. Maybe I'm not applying gzip compression, but you can also click on the timeline. I know this is the most intuitive UI ever, but you can click on this. That is actually a button. And you can resort this view, and you can say, you know what? The question I want to answer is, which of the requests or which of the assets that took the longest or were waiting the longest on the socket. So here you go. We just resorted this entire timeline based on latency, and you can see that this callback here was waiting for 20 seconds. I mean, that's just crazy. But we can scroll down and identify all the problems here. Same thing for duration. So instead of just saying, well, I'm only interested in the requests that are queued, here's a different request. This is ga.js. So this one, the latency is very low. We got an almost immediate response once we connected, but it took a while to stream the response back. So if you're into server-side optimization, there's a lot of very interesting data that you can discover just by looking at this view. So let me resort it back into timeline view, and this is what you're used to seeing. So let's head back. And I'll show you another kind of interesting example in here. Look at this utm.gif. So this happens to be a Google Analytics request. So we're sending an analytics ping. And let's look at the size. We're actually sending 855 bytes of data, but we're getting a response back, which is 35 bytes. And that actually makes sense because this is an analytics ping. This is just a beacon request. So we're sending some data, and we're just getting like a 204, no response here. But this shows you the overhead of HTTP. In fact, the average overhead of HTTP response and request headers is about 700 bytes. Right, so for every, if you're sending 10 bytes of data in HTTP, we're going to add on average 700 bytes of HTTP headers. Plus, if you have cookies, then we may be talking in kilobytes. So lots of data hidden in here. The other one that I'll highlight is, if you ever paid attention to the initiator column, this actually tells you who is scheduling this resource. Now, why is that important? Well, you can have multiple ways on how to schedule resources, and we'll look at a diagram of this in a second. But you can have a document parser schedule, for example, a JavaScript file, or you can have a script. And this tells you which part of the infrastructure of the browser is actually doing this. Why is this important? Well, we already kind of hinted at this. There's this deceivingly simple page that I have here. It's literally one HTML file and one CSS file. But there's an entire performance story in this simple example. So let's see if we can figure it out. First of all, we make a request for the HTTP page, right? And we can see that the total time that it took to render this page is 1.1 seconds. So that's the time to completion. However, the latency is 9 milliseconds, which means that we've opened this request and the server almost immediately sent us some data, useful data back that we could start parsing. And how do we know that we can start parsing it? Well, because almost immediately after that, we actually schedule style.css, right? So more likely, or likely, the server pushed some data, like the header data, which contained the reference to style.css, and we opened the request for that. Now, the styles.css is a completely different story. This one, if you look at the total time, it took us 1 second to fetch the file, but the latency is 1 second, which means that this request was queued for 1 second on the server for whatever reason. So this is a very good hint if you're doing any sort of performance debugging, like something really odd is happening here. Because once we stop waiting, or once we're out of that queue, the response comes back almost immediately, right? And lots and lots of interesting patterns that you will find like this hidden in your network waterfall. So I really encourage you to play with it. And this is also why early flush is so important. So a lot of frameworks like Rails, Django, and others nowadays are kind of re-architecting their stacks to allow for early flush, which is to say, if you have a template, right, the template usually, like the header of the template, doesn't change all that often. Most of the time. Maybe you're customizing with a username or something like that, but we can actually flush that header even before you have the response and allow the browser to start building the page and start requesting the resources that we'll ultimately need to construct the page. So as a very practical example, Google search. The first thing we do when you send us a Google search request is we flush the Google header, because that header doesn't actually change. We do customize it, but the customization is done via JavaScript. So we don't even care what you've asked us. We've just flushed the Google header, because that allows the browser to start fetching additional resources and start constructing the DOM. And only after we do that, we actually look like, okay, so what did you ask us? Oh yeah, okay, that search query. Let's go find the actual body of the response and serve the rest. So this is early flush. This is why it's important. So how does, and so I hinted at, you have the document parser, you have scripts, and why is it important that we actually know who is scheduling these resources? At a very high level, if we look at how does the browser actually schedule resources, you have the network stack, right, running in your browser that is kind of feeding bytes into the document parser. Once we tokenize those bytes into something that looks like, hey, this is a script tag or this is an image tag, there's a couple of things that could happen, right? We construct this tree and we can say, okay, great, we're going to need this image, so we'll schedule it back on the network. Alternatively, if you're familiar with synchronous scripts can block the parser. So that's actually a very bad performance. That's a performance anti-pattern. And in that case, we actually don't want to penalize you too much, and we have this other thing called the preload scanner, which kind of forges ahead and looks for resources. It does a very shallow parse. So the preload scanner may schedule your resource. And perhaps the slowest way to schedule your resource is to actually have JavaScript schedule that resource. So why am I saying this? Well, today we have a lot of very popular patterns like Require.js and other loaders that schedule most, if not everything, through JavaScript. Those frameworks offer a lot of power. The problem is they hide all of the resources away from the browser. Think of the browser as a JIT. The more information you give to the JIT, the smarter we can be into how we fetch these resources. So not to say that these JavaScript loaders are a bad thing. They can serve a very good purpose, but be careful and think about the implications. So moving right along, WebSocket frames. If you guys are doing anything with WebSockets, we actually have support in Chrome for WebSockets. So let me open this here. I have an example. I'll just refresh this page. So this is just a demo server. It actually has a WebSocket server that connects. We can see that we have 2 users connected, and we can actually send some text, and that's it. And now down here, in your network panel, we actually have a new section called WebSockets. And if you go into WebSockets, this is your actual WebSocket connection. If we click into that, you can look at the headers and you can see all of the negotiation parameters. If you ever worked with WebSockets, you need special handshake and all the rest. But you can also look at the frames view, and the frames view shows you the data that is actually being sent as text frames, as ASCII frames across the WebSocket. So if you're building any sort of WebSocket app, this is a fantastic way to look at what data is going over the wire. Now, one comment I'll make is you can actually transport binary data as well over WebSockets. Of course, looking at binary data in the frames view is not going to be as useful, but that's because we have no idea what you're transporting when you're transporting binary data. All right, we got some live participation. Awesome. Now, I think this is like my favorite feature about Chrome DevTools. Well, actually, I'm not sure if that's the favorite feature, but it's definitely one of the ones that I use all the time. Did you know that you can actually export the waterfall? And why is this useful? Well, as I said, I do a lot of performance work, right? So somebody sends me a site and says, hey, what can we do to speed this up? I look at this waterfall, I kind of spot a few things, and then I take a screenshot, I mark it up, I put a pointer there and like fix that, and your problem's gone. I send it to them over email, and then they look at that and they're like, well, I want some metadata. Like, well, what was the header on that? And at that point, I've closed the tab. I'm like, sorry, lost you. So why is this useful? Well, you can right-click right in the network panel, and we give you two options: save entry as har and save all as har. So save entry will export all of the metadata about this request into just a JSON file that you can save. Save all as har will save the entire waterfall. So har stands for HTTP archive format. So think of it as all of the metadata required to construct this entire waterfall right here. So let me save this. Give it a har. So here it is. It's just a giant JSON file. And what can you do with this har file? Well, now you can take this file and you can attach it to a bug report, stick it into an email, do whatever you want. Once you get this file, there's actually a number of different tools available for you to visualize it. I love this example because it really shows that Chrome DevTools is itself a web app. So look at this. This is an actual web page. This is not Chrome DevTools. It just kind of looks like it. And that's because Eric, who built this tool, actually took parts of Google Chrome and just kind of, he's running it as a web app. So let me grab my har file and just drag it into here. And look at that. This is the same thing, but inside of your browser, right? So now you got this thing, got this bug report, you drop this file and you're like, okay, this is cool. I'm looking at this, you can still resort, you can do all the things that I told you. You can also click on this thing, see the actual headers. All of the information is in here. It's it's awesome. This is what you should be using. You even have timing data associated with it, headers, cookies, all the rest. So this is an amazing tool, and in fact, Peter and myself, who's also on the Chrome developer relations team, recorded an entire 1-hour episode of just like, here are the crazy awesome things that you can do with har files. There's a lot of very cool open source tools that will allow you to capture this data, har files, directly from the command line, so you don't even have to run Chrome to do this. You can log this data into tools like har storage, so you can build like a really awesome performance dashboard for your team or for your company. It's just with a couple of command line tools, which is really nice. And I'll show you this guy right here. I think this is awesome. So Phantom.js is a headless browser. It allows you to capture this data, but I'll show you this screenshot right here. So what did they do here? They used Phantom.js. So on every build or on every commit, they run a build server. Phantom.js captures the har file, runs it through YSlow, and feeds it into Hudson. Okay, if you follow that, you get this, basically the outcome is, you get this report as part of your build that says, this is your HTTP performance report that says, hey, you have 72 requests on this page, right? So you've automated kind of these performance checks on your app, which is awesome, because you can set arbitrary rules and say, look, we're going to use at most 3 web fonts, and we should keep our pages under 100 requests. I'm picking these numbers arbitrarily. Like, you can set these 3 thresholds, but you can have these performance checks as part of your build. So definitely play with it. I recommend that you check out the video. Now, we talked about the network. Let's get a little bit more into the rendering part. And rendering is important for a number of reasons. At a very high level, to kind of understand how the rendering works, we talked about getting the HTML and constructing the DOM tree. In parallel, we need the CSS object model, and then those two things come together to create the so-called render tree, which is ultimately what gets painted to the screen. And I'm not going to go into too much detail here. I actually gave a kind of a detailed overview of the stuff yesterday, so I encourage you guys to find the slides for that, and if you're curious, and learn more about it. But at this point, you should be asking yourself, well, rendering is important, of course, but I'm just building a web page, like 60 FPS. Do I need to worry about 60 FPS for a web page? That's just for games, right? No, that's definitely not the case. Turns out, especially as you're building more and more ambitious apps, not just web pages, you absolutely need to care about how smooth the experience is. And in fact, even for scrolling is effectively an animation that you should care about. So what do we have in DevTools that will help you highlight this? Well, we have a number of tools. One of them is the timeline view. So let me show you this. So I have Google Plus open here, right? And I have my settings panel open. So I mentioned show paint rectangles at the beginning. So this is a setting that you probably don't want to have on all the time, but when you're wondering about rendering performance, this is definitely the one that you want to play with. So let me enable this. So first of all, it's disabled right now, right? And as I hover over all these elements, nothing really happens. If I enable this now, as I hover over these elements, you can start seeing kind of these interesting boxes appear around some of the elements, right? And these are the outlines of elements that are getting repainted. So think of it this way. Whenever you interact with a page, we don't want to repaint the entire screen. That would be very expensive. So we have a lot of smarts built into the browser to figure out what is the minimal paint area that we can do to update the screen. And there are many things that you can do in your code to either optimize that or make that really not work too well. For example, in here, right, as I hover over the name, as you would expect, you have an outline around Patrick's name and also around his card, which is exactly what we want. This is just the area that needs to be painted. But let's hover over some of the other regions, right? And you can start seeing that, for example, for whatever region, for whatever reason, some of the areas, for example, let me see, where was it? There you go, right? This box is also getting outlined. So whatever it is that I'm doing is actually triggering a layout across the entire paint area, across the entire main area of Google+. That's a pretty good tip-off that you're probably, or maybe you're tweaking a style, or you're changing some CSS on that outer object that perhaps you shouldn't be doing, and it's forcing a relayout and a repaint of this entire area. So definitely play with it. Take a look at your own app with this tool and just look like where are the paint areas. As long as they're constrained, that's exactly what you want. Another thing that you need to worry about when you think about rendering is, we said we want 60 FPS. Now, 60 frames per second, we have 1 second to do all that work, means that we have 16 or 16.7 milliseconds to render each frame, right? That is your budget. Anytime you lay out the page and render the page to the screen, you have 16 milliseconds to do it. Now, technically, that's your total time. You need to give the browser a little bit of time to do its work, so really you should be kind of safe. Let's say stay within 10 milliseconds. And not only that, but don't forget that 10 milliseconds on your laptop or on your computer is different from 10 milliseconds on your mobile phone. So you should really kind of aim to be even lower, because those are underpowered devices compared to what likely you're running. So let me click on this, right? This is an animation, and that's a very weird heartbeat right there. But what I'm doing here is I'm simulating a timer that just runs, and it is just checking how frequently, like, is there any jitter in how frequently the timer is firing. This is likely, this kind of weird pattern here is likely because I have some other tabs open that are doing work. So something on my computer is running, which is creating this jitter. I would expect this timer to just fire every 16 milliseconds, and it should be just a flat line. So I'm going to click on this button, and this button is going to do about 5 milliseconds of work in JavaScript. It'll just do some computation, right? And as let me restart this. And as I click on it, nothing really happens. Now, look at this. If I click on skip 3, so skip 3 is about 50 milliseconds of work. And why am I saying skip 3? 3 frames, 16 milliseconds each, about 48 milliseconds. As I click on this, all of a sudden you get this really bad pattern, right? And if you kind of pay attention, the animation is also a little bit stuttery. But to really see it in effect, I can just click this, right? Skip 10. So this is what usually happens. You have some JavaScript running in your browser that is consuming 100 plus milliseconds to do some work, whatever that may be. You may be laying out a page, you may be computing some interesting function, and all of a sudden everything else in the browser stops. Remember that each page is essentially a single-threaded app, right? So as you're doing your 100 milliseconds of JavaScript work, nothing else is happening. We're not repainting the screen. There's no interaction. If there's any animations running, it's all stopped. So what can you do about that? Well, you can use something like web workers, which will push some of the work into the background or into a separate thread. Or perhaps it's even worth thinking about splitting that computation. So if you have 100 milliseconds worth of work, it may actually make sense to split that work into 5 batches of 20 milliseconds. And just kind of schedule it and say, well, run the next batch after I paint the next frame. So you can still have the responsiveness of your app there while you're doing this computation. Now, obviously, that requires a bit more work on your behalf, but I think it's well worth it. Now, here's kind of a very practical example of this at work. So this is an example we gave at Google I/O. So this is just kind of a silly app where, as I scroll down the page, it just moves the Chrome logos, right? So it's kind of like a funny effect. Now, if I go into my timeline, and we have this new frames view in here, and I hit record, as I scroll, you can see the performance of each one, and I'll explain what this means. And then let me add some costly effects. And look at that, all of a sudden, it's very different, and then heavy scroll, and wow, this is really becoming jaggy. So let's look at some of these frames. You can zoom in on any one of these frames here, and you can see that on average, most of these frames, let's actually go even closer. So each one of these blocks right here is 1 frame. And it tells you that, hey, this frame took 18 milliseconds to render. This frame took about 45 milliseconds to render for whatever reason. And we can actually go into each one of these blocks and say, well, we painted, the paint region was about 1,200 pixels wide, which means that we were repainting the entire screen, first of all. It took about 1.6 milliseconds, so not too bad, right? And you can actually see that most of the work was actually in recalculating style. But nonetheless, at the beginning here, this line right here shows you 60 FPS. And it shows you that for most of the frames, we were well under the budget. So this is your kind of smooth animation. Everything's good. Then we went in and added some of these costly effects. So the costly effects in this case were actually a CSS shadow and I think a gradient. So we just added 2 effects, 2 CSS effects. And all of a sudden, the paints starting taking a lot longer. Each paint is taking 15 milliseconds. So just repainting is blowing all of our budget for this kind of smooth animation. So we're definitely not meeting our 60 FPS criteria. And then later, we added some on-scroll effects. And this is unfortunately the most common pattern on the web today. I really encourage you guys to check this out on your own app. So what's happening here is on every scroll, we're kicking off some JavaScript event which just does, I don't know, some logic. For example, it's not uncommon to find some ad code running, checking like, do I need to reposition my banner? Because they have a floating element on the side and they reposition it with JavaScript, and that takes like 50 milliseconds. So what you're doing is you're blowing all of your budget there, and you're getting like 10 or 15 FPS back to the user. So if you've ever had this experience where you've come to a page and you start scrolling and it feels really jaggy, it's kind of like, right? Oftentimes I find myself in that situation. I'm like, oh man, it's got to be something that I'm running in the background. Maybe I should close Photoshop, like I need to get more RAM. It's a really good excuse to get that new computer that I've been wanting all the time. Turns out that's not actually a good excuse. None of those are valid excuses, I should say. If you actually open your DevTools, chances are there's some like rogue JavaScript running on every scroll event that is taking like 100 milliseconds and you're getting 10 FPS. So there you go. That's why you should definitely play with this and pay attention to it. Now, the other thing I'll mention is that, of course, ideally, you're 60 frames per second and everything is beautiful. It's okay if you can't meet it. Shoot for 30, shoot for 20, but be consistent. This is perhaps counterintuitive, but having a variable frame rate is actually worse because we perceive this really well. Having a consistent rate, let's say, is 30 FPS is better than having 2060, 2060, and jumping all over, because it'll still create that kind of jaggy experience. Another thing I'll mention is you saw me export the HAR data from the network timeline. You can do the same thing in the timeline view. So if you're trying to debug something, maybe you don't have the time right now, or maybe you want to send it over to your coworker or teammate, you can save this data, attach it to a bug report, email it to somebody, and then you can also actually load the data through DevTools. Which is unlike the HAR files. The HAR files, you actually do need an external tool to visualize it. Here you can just literally load the data and dive in. And I'm showing you kind of a very short snippet here. The export is once again a JSON file, and this JSON file is incredibly metadata rich. It has tons of information. So for every, for example, mouse move event, it'll tell you which is the function in JavaScript that is being executed, which file is it, what is the line number, what is the heap size. It's everything that you find in the timeline. So think of other ways that you could consume this data. You could build automated tools to just kind of quickly scan through this and highlight bugs or find problems. So very easy to work with and very, very useful. I'll show you how to find and eliminate JavaScript leaks or memory leaks. So as we build more and more ambitious apps, not just web pages, we are building experiences where the tab stays open for a while, right? Like, for example, think of Gmail. My Gmail is just open for hours at a time. And unfortunately, right now, it's not uncommon to find apps that are occupying more than a gigabyte in size per tab in your browser. Which is scary, and we need to fix that. So I think this is an area where we as a web developer community can definitely improve, and we could build better tools. But we have some support for this, tools that will help you do this. In Chrome. So let me show you an example here. This is an example that we have on our docs in Google Chrome. I'm not going to explain the code, but the basic idea is that we have these item objects, right, that we're going to allocate. And we have kind of a simple dumb loop, which is going to create a whole bunch of function or item objects, and then it's going to delete a whole bunch of item objects, except that it's accidentally going to forget to delete some of the objects. So let me refresh the page just to make sure that nothing funny is happening here. I'll open DevTools, and I'll go into Profiles. And what I'm going to do is I'm going to take a heap snapshot. So I'm just going to start this. It's snapshotting here. So this will show us all of the objects that are currently residing in memory, all the JavaScript objects, all of the DOM objects, all of these things, right? So this is just like a long list of objects, and there's a ton of them. And then I'm going to go back here, and I'm just going to click this action button. So this action button just literally runs the code that we're showing you here. So I'll run that, and I'm going to go back into Profiles, and I'm going to take another snapshot. So what I'm doing here is I have a base or a reference point. I've interacted with my app in whatever way. I'm taking another snapshot. So now we have two states, right? And of course we can toggle between each one and kind of compare what's at the top of the stack, etc. But ideally, what we actually want is a diff. Like, what is the difference between these two states? So you can actually do that. Instead of looking at the summary, you can say, hey, I want to do a comparison, and it automatically picked snapshot 1 for me because that's the only one I have. But look at this. Instead of giving you like a long list of here are all the objects that are living in the VM, we're giving you just the diff. So in the actual diff is just 2 items really here. So here's the item object that we were allocating. We created 11,000 new objects from the start state to the new state. We deleted 10,000, and the delta is 1,000. So over the lifetime over the interaction time, we've basically accumulated 1,000 objects. Now that could be as expected, or that could be a bug. In this case, it's definitely a bug. And you can even open this up and look at the actual objects, see what they are, inspect them, so on and so forth. Now, this also works for DOM subtrees. So for example, you have a templating engine or you're building some subtree of the DOM, and then you forget to either remove it or you don't ever attach it. That's a memory leak as well, and it'll persist. And this same tool will allow you to find these things as well. So this is a very easy and simple way as a sanity check to find out how your app is doing. So definitely check it out. Getting out of the profiles and into the audits. So audits is, in fact, I think the power of audits is in the fact that it's easily extensible, and we'll see this in a later slide. By default, we provide a couple of built-in audits in Chrome. So let me show you. Actually, no, I'm going to go back to here. So let me go into audits, and you can see that we give you the network and the web page performance audit. So this is kind of like a simple check, a sanity check, if you will, that we run against your page to see, is there anything that you could improve about this page to make the page perform better? So I'm just going to hit run. So we run the audit, and we give you some recommendations. For example, it looked at all the requests that I've made, and it's saying, look, you could really leverage browser caching more. So it means that some of the assets on this page are not being cached, so we're forced to refetch them every single time. And of course, you can expand this and look at the actual requests. Now, the one I want to highlight here is this guy, remove unused CSS styles. This is actually incredibly handy. So if I open this up, you can see that we've actually shipped about 46 kilobytes of CSS for this specific page, but 78% of that CSS is not being used on this page. Right? So most of it is just kind of this inert code that is not being applied on this page. And in fact, you can click on any one of these style sheets, and it'll list all of the styles that are not being applied. So if you really care about the load time performance of maybe your index page, this is a great way to find out, like, how can I minimize my CSS, or how can I eliminate some extra CSS? Maybe it should be separate files altogether. This is a very, very, very handy tool for that. And we'll come back to audits actually in a second. The other tip I have for you is think of the audits in Chrome as kind of this very lightweight check. If you want a more in-depth look at the performance and the recommendations, definitely install the PageSpeed Insights extension. So the PageSpeed Insights extension, actually I'll show you an example. I have it here. So I just have CNN open. I'm not picking on CNN, just an example I like to use. I have the extension installed, so I actually have this new pane in my Chrome developer tools called PageSpeed. So I'm just going to hit Analyze on this. You can actually see that it's grabbing the HAR file, the HTTP archive file, and it's running a whole bunch of analytics on this file for how can we optimize the page. So here you go. Let me make this bigger. So this page is getting 80 out of 100. This is just kind of our general score. And then in the left sidebar here, we have a number of recommendations that we're making. So these are specific to this page, and we're saying, once again, there's a whole bunch of assets which we're downloading that are either not getting cached, or they have a very short cache time. So perhaps it could improve that. There are images, small images, that perhaps could be combined into CSS or sprites. Serve resources from a consistent URL. There's a whole bunch of things. I'll show you one that I found earlier. So optimize images. I love this guy. So we have an average page on the web, I should say, is about 1 megabyte in size. And about 60% of that megabyte is images. Unfortunately, we're not using the right image formats most of the time. We're saving images as PNGs that are better solved as JPEGs. We're saving JPEGs at 100% quality when they're frankly much better compressed at 50% quality without any perceptible or noticeable difference, while the file size is like 10 times smaller. So this example I love. So look at this. This file, newsdivider.png, is 46 kilobytes. Let's click on it. Do you see it? It's a news divider. It's like a 1 pixel image that is just like sitting there. I don't even know what it is, right? So let's go back. Look at that. When we looked at our tool and we said, look, hey, like we could compress this file by 99%. And I can not only that, but you can click on See Optimized Content, and here's your optimized version. I still can't see it, but that's beside the point. Right? So we took a 46 kilobyte, 1 pixel image, and you can just download it and you can right-click or save as and overwrite your original assets. So image optimization is built in with this tool. And then you can see other examples. So for example, this GIF file, we can actually reduce it by 34%. And this one is actually legitimate. It's a ginormous GIF file with a whole bunch. This is a CSS sprite. Right? So by just applying some of these optimizations, we could have removed about 100 kilobytes worth of data off this page, which is incredibly important, especially when you think about mobile. And actually, let me go back. We have a lot of useful tips and recommendations in this tool, so I definitely encourage you guys that you play with it. And if you are not familiar with any one of these, like for example, enable keep alive or defer parsing, like what does defer parsing even mean? And we actually have a lot of good documentation, so you can just click on this learn more link. You'll be taken to our Google developer site where we can explain what this optimization is. So with that, that's kind of some of the high-level things that Chrome provides for you today that you can just make use of today. And now I want to take a look at some of the extensibility of Google Chrome and what are the kinds of things that you can do and why does it even matter. So first of all, we talked about the audits panel. And the thing I like about the audits panel is really it was designed for you guys to extend it. It's not about the two really kind of simple checks that we have in there. Instead, if you have any sort of semi-repeated work that you have to do every single time before you release an app or before you do anything, this is the tool to automate it. So for example, literally in about 10 lines of JavaScript code, we are building a plugin that will, it's kind of a silly plugin, but it says, I'm going to look at the font size on the page. And if the font size is too small, it's not legible, I'm going to flag that as a concern. So you could do the same thing for checking for 404s or doing anything on your page. If you have certain best practices, or you need to check that you have, I don't know, a TM beside every other, whatever, trademark word, you could just hard code this, or you could build it as an audit. You hit run, and you get a report like this. So if you see this code right here, we're saying create result, details, 2 styles with small font. That's exactly what's showing up in here. So you have this really nice declarative API for generating these reports using the audits panel, and it's very easy to drop in. And once again, if you're doing work that you're repeating every single time, this is the way to fix it. If you're building tools for others, like if you're a framework author, you could use audits because you can just ship that extension and say, run this to check for best practices. An extension to this is custom panels. So you kind of saw this with the PageSpeed extension, but we do provide an API for you to embed new functionality into DevTools. Very similar workflow, it's just JavaScript. So for example, here we have this font picker extension, which is literally, you give it a HTML file, which is what's living in here. And for example, if you have a custom templating engine and you have custom properties on some of the elements, you can actually extend the functionality. You can click on that element and then you can have a custom panel sitting on the side in Google Chrome that says, here are the properties, or here's my custom logic for this element. So very, very powerful, and I've seen some really cool apps leveraging it. So play with it. Now, this one I love. I feel fine admitting this, but I spent way too much time customizing all of my IDEs and the colors in every IDE. Good news, right? We spend a lot of time in Chrome DevTools. You can do the same thing in Chrome DevTools. We provide a custom style sheet that you can drop in across any platform, and you can completely override all of the styles. So you can make it look perfect, just perfect, with the rest of your system. And that sounds silly, but I know it's important. So if you just follow the link, Adi put together this really nice list of some of the themes that are already available. And you can have some really beautiful stuff in here, so you can match it to whatever you like. But once again, this kind of hints at the fact that DevTools itself is a web app, and I'll show you this kind of very hands-on in a second. Remote debugging is really, really powerful, and if you haven't used this before, you definitely should. So there are 2 ways to use remote debugging. You can either start Chrome by passing this flag, with remote debugging port 9222, this basically enables an HTTP server within Chrome. Or if you're using your mobile phone, you can set up a port forwarding rule using the Android debugging. That's what I'm doing here. I'm just forwarding the TCP port 9222, and then you can connect to it. So let me show you this in practice. So here I'm running just regular Google Chrome, and I'm going to start another Chrome, which is the Canary version. And when I started it, I'm going to pass it this flag, remote debugging port 9222. So let me run that, and here it is. Right, I'm going to open google.com, and then in this guy right here, I'm going to go to localhost 9222. And look at that, we have Google. So if I click on this, I'm looking at the Chrome developer tools of this instance, right? So notice that as I'm hovering over the elements here, they're getting selected in another runtime. This is a different process. So we're remotely interacting with this other Chrome instance. And just to prove the point, this is kind of a little bit meta, but this itself is a web app. So we can run the developer tools on the developer tools that is debugging the other page, right? You're not seeing double. We can literally click on audits right here and just like, yeah, I don't like you, so I'll delete you. Oops. Delete node, there you go, right? So this is a web app. And so how does Chrome developers actually do this? Well, developer tools is just an HTML app, and where we're getting this information and this interactivity here, communicating between the different processes, we actually have a WebSocket connection that does it. So let me close this tab right here. So you can actually connect to it from outside of Chrome and do other interesting things. So here's a very simple kind of Ruby script that can connect to Google Chrome. So remember that we started Chrome on port 9222. I guess in this example I'm using 9292. But you can actually query Chrome and say, hey, what are the tabs that you have open? That's the /JSON endpoint. And then I'm going to grab the first tab here, and I'm going to connect to it with a WebSocket connection. And then once the connection is open, I'm going to send it two commands. The first command, ID 0, is called network.enable, which basically says, hey, Chrome, I want you to start logging network information. So think of it as opening your DevTools and clicking on the network panel. That's effectively what we've just done. Right? We're just enabling, we have this debug protocol, we're saying enable network debugging. And then I'm going to send the second command, and this command is going to say, hey, tab, please navigate yourself to Twitter and search for DevTools. And it would literally navigate the tab to that destination and then start spitting out all of the network information coming back to you. How does that look? Well, you're going to get JSON payloads that look something like this. For example, this is an event called network response received. Pretty self-explanatory. This is an AJAX request, so this is an XHR request, and it gives you all of the metadata about how Chrome made this request. So for example, I got a 200, you have the status type. We have all of the timing information, like how long did the DNS lookup take, how long did the TCP connect take. All of that is available. Also, how did we hit the cache? Did we have to actually make the request? Tons and tons of data. So why is this interesting? Well, you can actually build additional tools on top. You can drive Chrome remotely. You can consume this data. You can build your own infrastructure to find issues, to debug, and do interesting things. But not only that, right? So that highlights the fact that you can drive Chrome and consume data out of Chrome. But nobody said that you can't just generate the debug feed from somewhere else. Like, it doesn't have to be Chrome. We know the protocol. In fact, the Chrome debug protocol is well defined. If you can generate a feed that looks like it, then you can feed it from anywhere. And this is an example I love to share. I'll show you this here. So this is a project by the guys at Square. And they built this, it's an open source project called Pony Debugger. And as the name says, so remote network and data debugging for your native iOS apps. So what these guys have done is they said, look, we spend a lot of time in Chrome DevTools, we like and love Chrome DevTools, but we also build a lot of native apps, in this case iOS apps. So what we would like to have is ability to debug our iOS apps in Chrome DevTools. Just Pretty awesome. So what they're doing is they've instrumented all of their NS URL connections and all the rest, all those requests, to emit this WebSocket protocol that Chrome DevTools consumes. And then they just connect to it, and they're using Chrome to debug all of the interactions as they're happening within their native iOS apps. So this is your network waterfall, and then in here I'm also showing you they actually hooked it up to core data as well. So they're literally navigating the core data objects in Chrome DevTools, and you can see all the properties and all the rest. So this is pretty cool. Think of other ways that you could generate, or from where you could generate a feed like this and leverage all the functionality in Chrome, in DevTools, I should say. Now, benchmarking is a very hard thing to do. And it's hard to do because it's very hard to do it right. There's way too many ways you can get it wrong. And the reason for that is there are way too many layers that you need to worry about. Did you close all the socket pools? Did you flush your DNS? Does closing and refreshing your browser actually accomplish all of that? Well, I'm not sure. Did you forget to close your browser? Well, good news. We can help you, and there's a great extension to do that. So for this one, you will actually need to install an additional Chrome extension. Here's the URL. You can find it in the slides later. And let me close this. You need to install the extension, and then you need to actually run Chrome, just as we did with the remote debugger, but you need to pass this flag called enable benchmarking. And what this flag tells us is it actually opens up sub APIs for this extension to allow us to flush all of the connections, close DNS, kind of reset the blank slate, if you will, and do it reliably. And then I actually have it packaged into this little app, so I'm going to start it. This is going to be a separate instance. Let's see, there it is. This is the extension, so I can just open this, make it bigger, and for example, devox.com. I'm going to run 2 iterations on each, and let me just hit run on this. And what it's going to do is it'll literally open the tab. Well, I guess there's a bug on the Devox page. Let's just do Google. There you go. Oh, it's a redirect, that's why. So, in any case, it opens the actual tab, it'll get the timing data, and it'll log it in here. So it's literally opening and doing the full load experience of each of these pages. And then we give you the standard deviation, the first paint time, the load time. We can even test against things like, are you using Speedy or not? Will Speedy help you? And you can even compare the runs and kind of get a nice graph out of this. So all this functionality is baked in. You can even feed it just an entire URL file, so you don't have to feed it one by one. And this is the tool you want to be using if you're benchmarking either multiple iterations of your app or maybe benchmarking multiple apps. So with that, we have just a few minutes left, so I'll show you a couple of quick tips. We kind of talked about Chrome networking. Chrome networking has a lot of very extensive debug information. For example, predictors shows you all of the data that we have about your Omnibox patterns. Like, let's say you start typing AMA, and Chrome for me guesses that I want to go to Amazon.com. You can actually look at this data, and you can look at that kind of prefix tree and figure out your own patterns, which is kind of cool. But the one tool that I'll show you here is ChromeNet internals. If you haven't seen this, you should definitely play with it. This is where you'll find all of the networking information of Google Chrome. So things like, hey, what are the open sockets? What does the DNS currently look like? Am I using a proxy? Am I using pipelining? How does my cache look like? What is the size of my cache? All these things. So for example, for Speedy, if you're curious about Speedy and you want to understand how it works, when you open it in your network timeline, it'll look just like a regular HTTP request. That's the whole point. But on the wire, it is different. So let me show you this. I have this silly example, Speedy.io. It just says hello world. But now that I've opened this connection, it happens to be over Speedy. I can go back into here and look at this. We have a host connection. It's running over Speedy version 3. I can click on it. and it says there's one session running over this connection right now. I can click on it, and you can see the actual data being exchanged on the wire. So these are the speedy frames. So this is a very kind of low-level debugger, but incredibly useful for networking information. Incredibly useful for networking information. So once again, check out some of these tools right here. And then finally, we have Chrome tracing. So Chrome tracing is an awesome tool that we built at Chrome for debugging Chrome. Except that a lot of people, other people have found it to be very useful, and I think more and more people are using it today. So the idea being that I would like to see what are the internals of Chrome doing, like when I'm doing a rendering. So you can actually go to Chrome tracing, and you hit record, and for example, we can go back to here and just kind of scroll around, and we come back, stop tracing. And you have this very low-level trace of everything that is happening within the browser. So you have all of the threads, like GPU thread, renderer thread, and for example, we can zoom in on some of these regions and see that, for example, for this frame that we're rendering here, what is the exact code that is running within WebKit? And the cool thing about this is now you can take this code, or you can take this name, stick it into your favorite search engine, and you'll find the source file, and you'll read through the source file and be like, yes, I understand what this is doing, I understand why this is blocking. But not only that, but you can also instrument this with your own metadata. This is the awesome part of this. Not only will you be able to see what is Chrome doing, but in your code you can have things like console time update and time end update. This creates this kind of bar right here, which shows that this is my code running, and then you can cross-reference it against the functions that are running in kind of the outer scope of the browser. And given this information, you can really figure out where is the latency, what's happening in the browser. If you're building games, if you need high kind of really responsive apps, this is the tool that you want to use, because it'll show you the guts of what the browser is doing. So with that, I have this thing telling me my time is up, and we're at the end. So if you guys have any questions, I'm happy to answer. If we can get to it now, I'm going to hang around here. So thank you, and any questions?